Okay, so we're back to Ada Potato, and we're going to tackle the first modification. We need to make Ada move, and the instructions want to make it clear that Ada moves, but the potato does not. So we want to have some sense of independence there. Now, when we are talking about making a change like this, it's going to start with a modification to the world. The game is changing its very nature in this case. The state of the world at any given moment needs to incorporate Ada's current position. It's no longer a fixed static thing. It's something that changes from frame to frame over time in some way. Movement often requires some kind of X and Y position. Depending on how sophisticated you want to make things, it could be even more complex than that. But at the very minimum, we're going to have it have an X and a Y. So we take our existing game model, and we're going to add in two new fields, X, which will be an integer, and Y, which will be an integer. The X value represents Ada's X position on the screen. And just to be clear about X, I mean the horizontal position. And the Y will be Ada's vertical position on the screen. So, if we update our world model, the record, then we must also update our initial world correspondingly. We'll say that her initial position should stay in the center of the screen. So we'll give it window width divided by 2, and the Y can be window height divided by 2. We could choose a different position. So for instance, we could keep her in the bottom left corner or the top right corner by just doing window width, window height. But often we want to put her in the center of the window. We go further down now that we've modified our, so let me just say we've modified our world definition. We have the idea of an X and a Y that we could adjust, but that's step 1 of 3. Just because we have the model of the world doesn't mean we've actually changed the behavior of our game. At this point, let's start making it so that we can render based on the decisions that we have here. Now, previously we had draw image centered, and we were using that to draw either the Ada or the potato at different spots. And, at the same spot, which was centered in the screen. And that worked fine when Ada and potatoes were both stationary, but now Adas are able to move. We have several options. At the very least, we probably want to keep draw image centered around, just so that we can rely on that behavior for potatoes. Potatoes don't move, so we don't need to incorporate the world's X and the world's Y for that information. Instead, we'll focus on replacing this use of draw image centered. One option, we just call arcade draw texture rectangle, passing in the appropriate parameters. We want to use the world's X and the world Y, similar to what we did for game 1. That also requires the image's width, the image's height. We could extract this into a helper function. It's a little bit more complicated though, because we would still have to consume an X and a Y, and at that point we've really just recreated draw texture rectangle. It can be really tough to decide when you want a helper function and when you don't, and it's largely driven by need and aesthetics. You don't necessarily know offhand which one's better up front, but sometimes you go back and you look at the code and you make that kind of decision afterwards. I originally didn't have draw image centered, but when I was going through the code, I found I was redundantly writing a lot of code between these two functions with my draw texture rectangle, and I decided to extract it into a helper function. So for now, I'm going to leave it like this, very similar to what we did for game 1. And at this point in time, we should be able to have the same functionality we used to have. We still have Ada being in the center and the potato being drawn in the center. We haven't started making Ada move, but we now have the potential in our update world to manipulate the X and the Y. So one simple option is just every time we call update world, increment the world X by 1. And this will cause Ada to fly off screen very slowly. Since it remembers the X position, she'll continually be moving all the time, even when she's not visible as a potato. It also means that she's able to leave. We have a lot of different options for how we can make this work. If we wanted to, we could have her stop when she hit the far wall or bounce, but the directions are not very specific. So another very reasonable option, random.randint, which allows us to pick a random number between two other integers. We'll say a random integer between the window width and 0. So now she'll just teleport randomly horizontally whenever she's on screen. And this is not too dissimilar from the real Ada, who runs around very excitedly. If we felt that that was a little bit too fast, another fun option, choose a random number between -4 and 4 and be incrementing the x value. And then she wiggles a little bit when she's on screen. And over time, she'll be moving a lot more. You have a lot of options here in terms of making her only be moving while she's visible. So for instance, when the world mode is equal to Ada, only then do we update things. And that would keep her from moving when she's not visible. You also might consider that when the timer resets, you also make her reset, her position. So change the world X and the else condition here to reset her to the window width divided by 2, the center of the screen. So now, no matter how far off she gets, she'll always return to the center when she reappears. We have a lot of different options that we could use to make her move, and that represents a lot of possibilities you have when you're making a game, like Ada or Potato.